Welcome. We're going to solve some surface area problems for prisms, surface areas of prisms. Right? Here actually we're going to be working with triangular prisms, and here's our first problem. So the height of the triangular prism below is 11 feet. That's referring to the height of the prism. Right? That's the distance between the bases. Right? So the height of our prism is 11 feet. All right, now we also need to find the area of the base. Let's continue reading the question. All right, so the base height is 3 feet. All right, this here is referring to the altitude, and we're going to use that to calculate out the area of the triangle. All right, the area of the base. So the base area, right, is going to be 1/2. Right, we need this value here. I'm just going to leave parentheses there, times the altitude of that triangle, which is 3. The altitude is always perpendicular to the base. Now, it gives us a little hint here. It gives us a big hint. The triangular base is an isosceles triangle. Right? So these two are congruent to one another. That's also 5 feet. And in an isosceles triangle, I'm going to move this a little bit. The altitude splits this into two congruent parts, right? So this side over here is congruent to this side. So that altitude splits that third side into two congruent segments. Right? So, and we see we have a right triangle that's created by the altitude. So if we work with just this triangle, or the other triangle right next to it, since they're identical, we can find out the measure of this part, this half of the base here, right? This side in the right triangle, this one here. I just put the congruence marks in red there. So we can find that side, and then if we double it, we'll have the whole length, right? The whole length of this little b, the little base of the triangle. Right? So to find, let's just call this x. Boy, the orientation is leaving a little to be desired. Right? So we're going to find x here, and then we'll use that to find little b, this whole side here, which is so well drawn, so beautifully drawn. Didn't feel like I didn't orient, and I guess I should have. Let's see if I can make that kind of straight. Oh, that's not too bad. All right, so we have x squared plus 3 squared equals 5 squared. So that's x squared plus 9 equals 25. Subtract 9 from both sides. X squared is equal to 16. We only want the positive square root because, square, it didn't end up where it's supposed to. Because this is measurement, and measurement has to be positive. So 4 is x there. If we double it, we get the whole length of the base there. So 2 times 4, or 8. Right? So that means to find the area of that triangle, the area of the base, we're going to take 1/2 8 times 3. That gives us the area of the whole base, which is the same as that one over there. All right, so that is going to be b is equal to 1/2 of 8, which is 4, times 3 is 12. All right, so 12 feet squared is the area of the base. All we need now is the perimeter. To find the perimeter, we add up the 3 sides. Right? 2 of the sides are the legs of the isosceles triangle, so that's 5 plus 5, and the third side is the base we just found, which is 8. All right, so add that together, and our perimeter is going to be 18 inches. So now to find the surface area, I'm going to switch colors here. Surface area, and this one is in your notes, so I hope you're taking good notes. It's going to be 2 times the area of the base. Right? So actually, I'll write the formula. 2 times the area of the base plus the perimeter times the height. So that's going to be 2 times 12 plus 18 times 11. So that's 24 plus 18 times 10 is 180 plus another 18 because it's 11. So that would be 180 plus 18 is going to be 198. So most of our area comes from those sides. And so that's going to give us 222 inches squared. And we're done with this one. Right, so this podcast is going to have, I think, 3 problems on it. The last 3 that we didn't do yet. We want to find the surface area of the right prism. Notice we have on our triangle base here, we only have one side at an angle. Well, this triangle is a special triangle. It is a right triangle, which means that we can use our trig relationships to find the missing side. Right? So we actually need both sides, both of our missing sides, because we're going to need it for perimeter. Let's call this side x, and let's call this side y. So to find, let's label our sides relative to the angle. So 4 here is opposite the angle. That would be the opposite side. X is next to the angle. It's adjacent to the angle, so it's the adjacent side. And of course, y is opposite the right angle, so it is the hypotenuse. So x, we want the adjacent. We know the opposite. Opposite and adjacent, that's tangent. Right? So if we take tangent 20, that's going to is equal to 4 over x, opposite over adjacent. Now we need to isolate x, and the very first thing we need to do is get x out of that denominator. So we're going to multiply both sides by x. So we have x tangent 20 equals 4 divided by x times x. That will cancel. So now I have x tangent 20 equals 4. Divide both sides by tangent 20. Right, so x is equal to 4 divided by tangent 20. And now it's a calculator problem. We just have to find the ratio that goes with the tangent of the 20-degree angle. And that happens to be x is equal to 10.9899. Let's call that 11. That's really close. All right, let's round that to 11. Right? So x, actually right over here, x is equal to 11. That enables us, what happened to the other one? Oops, well, a little off there. Now it just looks like a fat 1, not like an 11. So x equals 11. I'll take it. Right? And so now we can find the area of the base, right? Because the area of the base is determined by these 2 perpendicular measurements, right? The legs on the right triangle, right? You always use perpendicular values to find your area of anything at all, right? So the base area is going to be equal to 1/2 times 4 times 11. Half of 4 is 2, and so 2 times 11 is 22, well, just call it inches squared. All right, so that gives us the base area. Now we need the perimeter, which means we need to know the other missing side. Right? So we know and by the way, do not use the adjacent. I rounded, right? That's why you can't use Pythagorean theorem. That's a rounded value. You need to use the exact values. 20 degrees is exact. 4 is exact. Don't use a rounded value again, otherwise you introduce rounding error. All right, so sine 20 is equal to 4 divided by y. The isolating is identical. We're going to multiply both sides by y, so y sine 20 equals 4 divided by y times y. Right, we multiplied both sides by y to get rid of that y. Well, I almost canceled it out. Very close enough. All right, so now we have y sine 20 equals 4. Divide both sides by sine 20. So we have y equals 4 divided by sine 20. And now we plug into the calculator. Oops. I was trying to get, no, it's all connected. I was trying to fix my division bar, but the orientation's so off that it was in the wrong spot. All right, so if we plug that into the calculator, we get y is equal to, round that to 11.7. All right, so now we can find our perimeter. Right, so we needed that base area. There's that. There we go. We need the perimeter. So the perimeter is going to be equal to, we just add up the 3 sides of the triangle, so that's the perimeter of our base, 4 plus 11 plus 11.7. Come on. Come on, the rest of my numbers. There we go. All right, so that's going to give us a mess, actually. That is so hard to read. That just looks terrible. I don't want to. It's that whole side of that board. Just doesn't like me. Let's put the perimeter way over here. Right, so that's going to be 4. Now, here it comes. And it looks much better. All right, so that's going to be 11 plus 11.7, that's 22.7, plus another 4 is 26.7. Right? And so now all we have to do is use our surface area formula with all of our important values, the base, the perimeter, and right here is our height. Right? Our height is the distance between the bases. So the height of the prism is 9. I've used up so much space because I wrote so big. Now I've got to find some little corner to do the surface area in. Oh my. All right, I am going to try to squeeze it on the bottom here. So our surface area, I'm not writing the formula this time, is equal to 2 times the area of the base. Come on, there we go. 2 times the area of the base, which is 22, plus the perimeter, which is 26.7, times the height of the prism, which is 9. Ah, my parentheses went right over my 7. I was trying not to look. I'm trying to write fast. I'll never get in that spot, but let's see how it goes. If we just move it over a little bit, it'll all be good. And then we add the missing decimal point, which ended up in the wrong spot and probably won't move. Oops, we're moving this the 6. How about, can we move the decimal point? Come on, decimal point. Come on, you can do it. Just move over so we can read it. Ah, sometimes it does everything but what I want it to do. Simple. We'll go and try to use the mouse. Come on, computer. I know, we'll turn my page. Ah, the joys of technology sometimes. So much effort to move a decimal point. There we go. Probably all laughing at me at home. There we go. God's good enough for me. And let's multiply. So this is 44 plus, I'm going to use a calculator for this one. 26.7 times 9 is 240.3. And when we add that together, I'm trying to decide where I'm going to fit this. I guess right down here. I hope you can see this. All right, so that's going to be 284.3. Whatever's, because there's not a unit on here. Units squared. There we go. Oh. Let's just say I did not use space well. Everything's so crowded together. I hope you can read this. I think if I move this over just a tad, that's all moving very nicely for me, unlike that decimal point. And then I can move this up. Oh, of course, I'm going to have to move the decimal point and all of these pieces. We have only one last problem on this tape, which is good, because moving things has just been the death of me. You know what? I think it looks fine where it is. It's going to have to be fine. Because, well, nothing wanted to move, quite honestly. Ah! I'd make this tape over again, but I don't really want to. All right, move everything over. It just seems like nothing's in the right spot. I'll write it real fast so you can read it. I won't even talk. I forgot to remember that number wrong. There, now I hope you can read that. It's not so crammed in at the bottom. All right, one last problem. Ay, ay, ay. All right, no issues on the next one. All right, so this is very similar to a problem that we did in class, only it was with a rectangular prism, and I showed you how if you chose x to be your height, it was an easier problem because you'd only have x one time in the equation. On a triangular prism, you do not get to choose. It has to be the distance between the triangle bases. You can't turn it around inside some other side is the base. But fortunately for you, x is the height. They are x apart. Right? So now we are going to be solving for this one variable. Right? We need to, first of all, we need to find the area of the bases. Notice we are missing a side. We're missing this one here. My little right angle got erased when I erased the board. This is a right triangle, because I say so. And so we can use Pythagorean theorem to find our missing side. This one's also in your notes. So use Pythagorean theorem to find the missing side. Probably should have wrote on the other page, use trig ratios to find your missing sides on that one. But with trig ratios all over the problem, I think you will have figured that out when you look at your notes. So this is x squared plus 8 squared equals 10 squared. X squared plus 64 equals 100. Subtract 64 from both sides, and x squared is 36. Take only the positive square root because this is a measurement, and x is 6. So now the area of our base is equal to 1/2 times 6 times 8, which gives us half of 6 is 3. 3 times 8 is 24 inches squared for once I put units. Perimeter of the bases, we just need to add those up. That's all there is to it. So 6 plus 8 plus 10 is going to give us 24. That's a coincidence, by the way. It just happens to be the numbers I chose. 24 inches. All right, and we have our height. So to find our missing, we're going to use our surface area formula. And we know the surface area. We are given that it is 408 inches squared. So 408 is equal to 2 times 24 plus 24x. Right? Just plugged in base, perimeter, height. Let's simplify. 408 equals 48 plus 24x. Let's subtract 48 from both sides. That's going to give us 360 equals 24x. And all we have to do is divide by 24, and that'll give us our missing height. So 15 inches is our height. And that's all there is to this problem. All right, so that's the end of surface area for prisms. In the next podcast, we're going to look at cylinders. Thanks for watching.